Well, hello, and welcome to lab number 6, Food Webs and Trophic Cascades. I wanted to provide a short introduction as to how to use this virtual lab simulation as you both perform your own experiment, collect some data, and of course, analyze that data as you go. So to begin with, the link that is up on Classroom, you want to make sure that you're going to the right part of the simulator. So in the upper left-hand corner, you want to move from lesson the producers to lesson food web. Okay. And what you're going to notice is that the default conditions give you a very simple, not even a food web, but a food chain from producer to herbivore to a single omnivore. And what you can do is you can either press step to, I kid you not, day by day, move through the simulation. Or if you prefer, just go ahead and press run, and it will run through all 100 days of the simulation for you, albeit a little slow. So maybe get up, go to the bathroom, get a drink while you are waiting. But what you're going to see plotted for you as the simulation runs are the population sizes of each of the three species that are present under the default conditions. So there's plant A, there's the herbivore, and there's the omnivore. So what you're going to want to do to begin with is record the minimum population size, the maximum population size, and the carrying capacity for each of these three species. Now, you want to be careful. The minimum population size will be pretty easy to find. It's going to be the smallest value on a particular day. So there it is for plant A. Looks like it's going to be here for herbivore A. Omnivore A is going to be a little bit trickier, but if you scroll around, you should be able to find the smallest population size. I would be hesitant to pick values that are at the very beginning of the experiment. Let the experiment run for at least a few days, maybe 5 days, maybe 10 days. I'll leave it up to you to decide as long as you are consistent before you actually record any values. When it comes to the carrying capacity value, you may have some familiarity with the concept of the carrying capacity. The carrying capacity is the maximum number of individuals that a particular environment can support at any moment in time. And oftentimes, those carrying capacity values are represented on population versus time graphs as plateaus. So if you can find the spot of the graph where the population size plateaus, you can use that value as the carrying capacity for each of the species in the simulation. And please be aware that you're not going to be able to get to a carrying capacity and stick at that carrying capacity for an indefinite amount of time. There may be some fluctuation. So you can choose a value for the carrying capacity. Having a slight difference in the number of individuals from day to day over the course of 100 days is not going to make that big of a difference. All right, so that is what you want to do for the default conditions. For the rest of the lab, as always, you have a choice. So there's two parts to the lab that I'm going to ask that you take a look at. One is to use the software to model a bottom-up trophic cascade, and to also use the software to model a top-down trophic cascade. And there's lots of different ways that you can use the software to model each of those trophic cascades. So what I actually did was on the sample spreadsheet, that of course, as always, is linked to Google Classroom. I've got my default conditions up top. Just talked about those. Here are the bottom-up values that I came up with using the simulation. And what I did was I just went ahead and added another species of producer at the lowest trophic level of this particular system. And I set it up so that this herbivore, ate plant A, ate plant B, and this omnivore is going to eat herbivore A. Okay, so I ran the simulation and I collected the data here. Again, minimum values, maximum population size values, carrying capacity values, those points on the graph where the line plateaus. Okay. You should be able to do something similar for a top-down trophic cascade using the software. I'm going to encourage you to insert images of your food webs into the space provided so that we have a clear understanding of what it is that you did in the using the software. And then finally, the last step of this is to go ahead and calculate a new value for us called Simpson's diversity index. And I move my face here a little bit. You'll be able to see the entire formula. It's a very simple formula. It's one of those formulas that would be provided for you on the AP exam. It's simply 1 minus the sum of these squared values. And what are these squared values? Well, it's the number of individuals of a particular species, which I tried to identify over here. And I went ahead and used the carrying capacity values for all of these calculations, divided by the total number of individuals in the community, which is right here. Okay, so in essence, what you're going to do is take the number of individuals of a particular species, divide it by the total number of individuals, square that value, sum all those values together, and then subtract that sum from 1, and you can see the formula right there. Okay. So by doing that, what you're going to be able to do is calculate a diversity index value, not only for the default conditions, but also for each of the trophic cascades that you set up, bottom up and top down. And what I'm hoping you're going to begin to see is that whether you set up a bottom up or a top down trophic cascade, there's going to be an influence on species diversity as a result. If you look at one of the examples that I set up for my top down model, I actually got the model to eliminate one of the species entirely from the system. And of course, that's going to lead to a decrease in the diversity index. Maybe it's surprising to you that even though there was a decrease, the decrease wasn't very large. There isn't going to be a way to analyze the data statistically in this case. We're going to be forced to just compare values, but hopefully you can see there is a decrease in the diversity index, but the magnitude is not as large as you might expect. All right. So I hope this video provides an introduction as to what I'm asking you to do for lab number 7, food webs and trophic cascades. As always, if you have any questions, don't hesitate to ask. Please be well.